Good evening. Myself Abhijayanu, 20MI1033, and the project I've chosen for natural language processing is Autocorrect feature. Our team comprises of myself, K. Anandakrishnan, and Mohammad Iqbal. In this presentation, we'll be talking about the following topics. We'll have a brief explanation about the project, its domain, about ontology, why we'll be using ontology, the main components of ontology, how to use ontology, the various procedures involved in the usage of ontology, and the various applications of our domain. About the project, natural language processing has been a growing area of research in computer and cognitive sciences using experimental approaches. Morphology and syntax play specifically a vital role in the correct interpretation of a sentence. In this project, we will present a syntactic error correction system based on the automatic generation of correct sentences in English. First, we extract the words from the considered sentence, and we then generate all the possible sentences that are syntactically correct, based on a logical description of the rules of English grammar in the ontology. We will afterwards compare the original sentence with the generated sentences to detect any eventual errors followed by the correction phase. In case the system has not found a sentence that looks similar to the original sentence, the correct alternative sentences are automatically offered. The use of English syntactic corrector can increase productivity and improve the quality of the text for anyone who writes in the English language. Successful tests have been performed using a set of English sentences. The implemented system achieved a precision rate of about 92% and a recall rate of about 84%. By observing the achieved results, it is concluded that our approach is promising. Introduction. Many works focus on natural language processing at several levels, namely morphology to define the structure of words, syntax that determines the composition of sentences, and semantics to determine the meaning. Several programs such as automatic translation, extraction of information, automatic text summary, etc., can exploit these. However, the defect of such software program lies in the relation between the words constituting a sentence that can be sometimes syntactically incorrect and which can therefore lead to incorrect results. This imperatively requires a system of automatic effective correction. Most of the work in this field deals with the spelling level. It simply verifies the existence of words in the dictionary but cannot detect syntactic errors. The objective of our project is to design a new approach capable of automatic processing of the syntactic errors of the English language. The word processing can be defined as any algorithmic manipulation of an input, in this case, linguistic signals for various purposes, such as categorization, comprehension reproduction, translation, etc. In our case, this word may aim to transform existing linguistic data for the purpose of detecting and correcting ungrammatical elements by generating sentences from words. The word automatic means having the capability of independently detecting or correcting errors without the participation of human and imposing serious constraints in order to perform the corresponding calculations. Domain. While natural language understanding (NLU) applications are evolving, they still frequently misinterpret spoken and written language. The reason for this is language ambiguity. Words in different contexts can mean different things. This makes things tricky for NLU applications that need to understand language intent. When you consider the integral nature of NLU to drive smart machines and autonomous systems, taking the right NLU approach is critical to optimizing outcomes and decision making. Yet, for NLU programs to succeed, they need a deep understanding of language structure and word classification. This is why it's important to understand how ontology works with NLU. Taxonomy and ontology work in different ways to apply structure to language. Taxonomy identifies hierarchies, while ontology defines the relationships between them. Together, they help disambiguate language so NLU programs can perform with more accuracy. What is ontology? Ontology learning, or ontology extraction, ontology generation, or ontology acquisition is the automatic or semi-automatic creation of ontologies, including extracting the corresponding domain's terms and the relationships between the concepts that these terms represent from a corpus of natural language text, and encoding them with an ontology language for easy retrieval. As building ontologies manually is extremely labor-intensive and time-consuming, there is great motivation to automate the process. Typically, the process starts by extracting terms and concepts or noun phrases from plain text using linguistic processors such as part-of-speech tagging and phrase chunking. Then statistical or symbolic techniques are used to extract relation signatures, often based on pattern-based or definition-based hypernym extraction techniques. Why use ontology? Today, people have access to more data from various sources, broadening to many different domains and information systems. The amount of data that can be accessed within a single day has increased over time when compared with the information systems we had decades ago. For example, if we look at an enterprise, the data sources can be found in many different forms like spreadsheets, databases, presentations, documents, visual diagrams, etc. Since these are all captured in many different formats, it makes it inherently hard to understand the relationship between different data. In a situation like this, it is very hard to understand how policies captured in Word documents relate to business processes captured in models, and how these business processes relate to data captured in the database, and so on. Data needs to be allowed to represent in a format where we can identify all these relationships and store. Ontologies capture data in a way that allows these relationships to become visible. An ontology is a form of knowledge management. It captures the knowledge within a certain domain as a model or a data model. This model can then be queried by users to answer complex questions and display relationships across the domain. According to the Tom Gruber, an AI specialist at Stanford University, an ontology is the specification of conceptualizations used to help programs and humans share knowledge. This means that an ontology is a set of concepts, or things, events, and relations that are specified using natural language in order to create an agreed upon vocabulary for exchanging information. Conceptualization is the breaking of the words into concepts in terms of entities, whereas specification is the representation of this conceptualization in a concrete format. The main components of ontology. The four main components of ontology are as follows: concepts, relations, instances, and axioms. Now let's take a deeper dive into all these components. Concept. A concept represents a set or class of entities or things within a domain. For example, case law can be taken as a concept in the legal domain. There are two different kinds of concepts. Primitive concepts. These are those which only have necessary conditions in terms of their properties for the membership of this class. As an example, for a doctor to practice in Sri Lanka, he or she should necessarily have the SLMC certificate. The second one is defined concepts. These are those whose description is both necessary and sufficient for a thing to be a member of the class. As an example, for a doctor to practice in Sri Lanka, he or she should have the SLMC as well as a degree. Relations. Relations describe the interactions between concepts or a concept's property. There are two kinds of relations. The first one being taxonomies, organize concepts into sub-super concept tree structures. The second one is associative, relationships that relate concepts across tree structures. The third component of ontology being instances. These are the things represented by a concept. For example, in the classroom system, Prof. Morris is an instance for the concept teacher. An ontology does not have any instance. It is merely a conceptualization of the domain. The combination of the ontology with associated instances is what is known as a knowledge base. The fourth component is axioms. Axioms are used to constrain values for classes or instances, like age should be greater than 0 and less than 120. How to use an ontology. An ontology can then be queried by users to answer complex questions and display relationships across a domain. This can be used to identify real-life relationships of the entities. Let's consider the following example. Peter, an instance of the class person. WSO2, an instance of the class organization. An ontology is capable of capturing the relationships between these two instances, and according to this example, it gives the relationship called has employer, read out as Peter has an employer, WSO2. As explained above, the combination of classes and relationships is known as a triple. A triple consists of a subject, object, and a predicate. This makes the heart of ontologies. Using these triples, they can all be combined in order to show the comprehensive view of the real world within an ontology. For example, if we get a triple where John is the subject, has employer is the predicate, and code jet is the object, this can be merged automatically or semi-automatically extract whole ontologies from natural language processing text. The process is usually split into the following 8 tasks, which are not all necessarily applied in every ontology learning system. Domain terminology extraction. During the domain terminology extraction step, domain-specific terms are extracted, which are used in the following step to derive concepts. Relevant terms can be determined, for example, by calculation of the TF-IDF values or by application of the C value or NC value method. The resulting list of terms has to be filtered by a domain expert. The subsequent step, similarly to co-reference resolution in information extraction, the OL system determines synonyms because they share the same meaning and therefore correspond to the same concept. The most common methods, therefore, are clustering and the application of statistical similarity measures. Concept discovery. In the concept discovery step, terms are grouped to meaning bearing unit which correspond to an abstraction of the world and therefore to concepts. The group terms are these domain-specific terms and their synonyms, which were identified in the domain terminology extraction step. Concept hierarchy derivation. In the concept hierarchy derivation step, the OL system tries to arrange the extracted concepts in a taxonomic structure. This is mostly achieved with unsupervised hierarchical clustering methods. Because the result of such methods is often noisy, a supervision step, example, user evaluation, is added. A further method for the derivation of a concept hierarchy exists in the usage of several patterns that should indicate a sub or supersumption relationship. Patterns like X, that is a Y, or X is a Y, indicate that X is a subclass of Y. Such patterns can be analyzed efficiently, but they often occur too infrequently to extract enough sub or supersumption relationships. Instead, bootstrapping methods are developed which learn these patterns automatically and therefore ensure broader coverage. Learning of non-taxonomic relationships. In the learning of non-taxonomic relationships step, relationships are extracted that do not express any sub or supersumption. Such relationships are, example, works for or located in. There are two common approaches to solve this subtask. The first is based upon the extraction of anonymous associations, which are named appropriately in a second step. The second approach extracts verbs which indicate a relationship between entities, represented by the surrounding words. The result of both approaches need to be evaluated by an ontologist to ensure accuracy. Rule discovery. During rule discovery, axioms, which are formal description of concepts, are generated for the extracted concepts. This can be achieved, for example, by analyzing the syntactic structure of a natural language definition and the application of transformation rules of the resulting dependency tree. The result of this process is a list of axioms, which afterwards is comprehended to a concept description. This output is then evaluated by an ontologist. Ontology population. At this step, the ontology is augmented with instances of concepts and properties. For the augmentation with instances of concepts, methods based on the matching of lexicosyntactic patterns are used. Instances of properties are added through the application of bootstrapping methods, which collect relation tuples. Concept hierarchy extension. In this step, the OL system tries to extend the taxonomic structure of an existing ontology with further concepts. This can be performed in a supervised manner with a trained classifier or in an unsupervised manner via the application of similarity measures. Frame and event detection. During frame or event detection, the OL system tries to extract complex relationships from text. Example, who departed from where to what place and when. Approaches range from applying SVM with kernel methods to semantic role labeling to deep semantic parsing techniques. Now, the applications for ontology. Artificial intelligence. This is an intelligence expressed by machines. Intelligent agents are the components that perceive its environment and take actions that maximize its chance of success at some goal. Semantic web. The semantic web is an extension of the web through standards by the World Wide Web Consortium. The semantic web provides a common framework that allows data to be shared and reused across applications, enterprise, and community boundaries. Systems engineering. This is an interdisciplinary field of engineering management and engineering that mainly focuses on how to design complex systems over their life cycles. At its core, systems engineering utilizes systems thinking principles to organize this body of knowledge. Software engineering. This is where the engineering expertise gets applied to the software development in a systematic method. Biomedical informatics. This is where information technology is being applied to the medical arena. It is a multidisciplinary field. Library science. This is a multidisciplinary field where it applies the practices, perspectives, and tools of management, information technology, education, and other areas to libraries. Enterprise bookmarking. This is a method for users to tag, organize, store, and search for bookmarks of both web pages on the internet and data resources stored in a distributed database or file server. Information architecture. This is an architecture which has a structural design of shared information environments. The art and science of organizing and labeling websites, intranets, online communities, and software to support usability and findability. That's the end of the presentation. Thank you.